Let's talk about some of the basic terminologies to make you aware about networking in real life. You may hear people talk about north-south or east-west traffic. What is that? Let's try to understand. When you have your data center, let's consider this as data center, and you have a lot of racks on which your machines are running. It could be physical server, could be virtual server, but these machines will communicate a lot with each other. Right? So let's say you have deployed a web server here somewhere. Let me use a different color. So you have web server running here on the server rack. You have a database server. You have an application server here. You have a backup server here. So these servers would communicate with each other. How these servers communicate? That happens through something called top of the rack switches, TOR as we call them, top of the rack switches. So this is a server rack and this is another server rack. Between them, there would be rack switches at the top. They are kept at top, and that's why they are referred as top of the rack switches. And they are connected, as you see, with this router, or there may be something like this. Let's consider this layer 3. Now, what happens here, whenever your machines is talking to from here to here, the traffic is being sent like this. So this will ensure that your traffic reaches to destination. Obviously, if I have kept my machines on the same rack, it does not need to go across the rack and then communicate. But most of the time when your application is distributed or had multiple nodes running in that, you would see lot and lot of east-west traffic happening. A study shows that 80 to 85% of traffic in a data center is a east-west traffic where internal communication is happening, maybe a backup server, maybe a fine-tuning happening, maybe there is a machine learning model, maybe there is a anomaly detection happening on network traffic, or maybe a database communicating to front end or back end. So that type of thing happens a lot, and that is referred as a east-west traffic, which is around 80 to 85% in a data center. And then you would have north-south traffic, as the direction shows that this is something which is traffic coming from internet or going out on the internet. So that is there, that is referred as north-south traffic. So these two common terms you will see people referring to, that we have a lot of north-south traffic, or we have implemented a firewall to control north-south traffic. We also implemented firewall for maybe east-west traffic. So these type of things can be implemented. So hopefully you are clear about it. Next common term you would hear again and again is TCP/IP. TCP/IP is a practical implementation of a OSI model. OSI model, as we discussed, was a theoretical model ensured to create that the device manufacturer or software vendor follow a standard procedure to work around. But that need to be practically implemented, and that is where TCP/IP came into picture. My mistake here, I have just to make this TCP and this remove this one. So this is my TCP/IP communication. So TCP/IP is ensuring that I am able to practically implement the layers of OSI model, but rather than having these seven theoretical layers, we divided TCP/IP into just 4 layers. And this is how the logical representation is. Data link and physical layer combinedly is referred as network access layer or physical layer. Network layer still remains internet, transport layer remains transport, and then these all are combined together into application. Initially, this TCP/IP protocol was developed by US Department of Defense, or defense personnel developed it to ensure that they could run a network even with a lot of severe interface interfering or severe network loss. They could communicate with each other in case of, let's say, there is a huge war and maybe a complete location is wiped out and there is no network communication possible, how we can still withstand communication. And that is where TCP/IP came into picture. And TCP/IP, though that is the two name which we see here, TCP and IP, but it is made up of multiple protocols within them. TCP and IP are the most common or most prominent protocol in this whole stack. TCP stands for Transmission Control Protocol, IP stands for Internet Protocol, but there are more protocols within that particular TCP/IP stack, like application layer, DNS, BOOTP, DSCP, FTP, web server, TFTP, IMAP, POP, point of your email protocol. So these all exist within TCP/IP. Same way in transport, you may have UDP. Internet layer, you may have routing protocol. You may have IP support like ICMP protocol. When you do ping to another device, that happens through ICMP. So it is not just two, but there are multiple protocol, and this is not exhaustive list. This is just some very basic information which has been provided. So that's what a TCP/IP stack is. It is ensuring that there are different protocol to support different function of a network. Like you would need a protocol to send your email. So that is post office protocol is email protocol POP. You would need a protocol to configure your host when they boot up. So that is DSCP. You would need a protocol by which you can check connectivity. So that can be ICMP. And the beauty of TCP/IP is that at the bottom layer, it can run on different type of physical infrastructure. It could be a Ethernet type of communication. It could be a interface driver. It could be PPP as a communication. They all can support TCP/IP, should not be a problem at all. And these drivers of TCP/IP or software of TCP/IP is built in into every device, I would say nowadays. All your hardware, software which you connect to internet would have this TCP/IP software installed or configured, or a package which will ensure you could communicate to it. Now, let's go and talk a little bit more on TCP and UDP communication. Common question in interviews also. So, if I compare how we have related these components to our to OSI model, so in data link and physical, they have been combined together, and in that case, we have MAC addresses to identify devices physically. Like you could identify a person by their fingerprint, right? That is a physical identification. Whatever name they have assumed, you can still go ahead and get their fingerprint, and maybe in a database you can search and check who they are. That is a physical addresses is your MAC address. IP address on network layer, we can decide what we want, and on transport layer, we work on TCP or UDP addresses. TCP, transmission control protocol, and user datagram protocol, they work on the same layer, but they have different functionality, and they are used for different type of communication. TCP is considered as connection oriented protocol, like making a phone call to someone. So you make a phone call to someone. Unless he or she picks up the phone, you would not start talking, right? So you need to ensure that the person, you probably call a person, hey, I need 2 minutes of your, do you have time? If they say yes, we can talk, then you can start communicating whatever you wanted to. That you are building the connection first, and then you are sending the information. UDP says, no, we do not have that much of time. Let me drop them a SMS, or let me drop them an email. Whether they read it or not, maybe that is not important for me. Just sending out information is important, and that time I may have used UDP, user datagram protocol, which is connectionless. It just sends a message without having any connection established, hopes that you would get it. In real life, think of it like you send somebody a postcard. Obviously, postal department would try their best to deliver this postcard to them, but there is no guaranteed communication received back by you whether they got postcard or not. It may have been lost also, you have no idea on that. Whereas TCP is sending something a registered mail, physical mail I'm talking about, like you have registered a mail and you want somebody to signature when they are receiving it. So that is received as a TCP communication. So it builds a connection and then transfer the traffic, whereas UDP just sends the traffic. TCP uses a sequence number. So it will say, okay, this is packet number 1, this is 2, this is 3, this is 4, and when the device receives it, it may receive 1 first, and then 3, and then 4, and then 2, but before it consumes it, it would reorder the message in 1, 2, 3, 4, and then will consume the message. So here is a sequence number by which we would be able to frame these things again at the destination, and there will be acknowledgement that, okay, I have received packet number 2, I have received 4, I have received 5, maybe the first one got lost, can you send it again? So there would be acknowledgement given to the destination to the source that package has been received or not. Whereas UDP tries their best effort but is not guaranteeing you. It is in a way unreliable. Even if you send 1, 2, 3, 4 and 3 is lost, that will not take any effort to ask for the third lost packet. So that's where you may not be having a reliable communication using it. But why don't we always use TCP? Obviously there is an overhead for communicating back and forth, acknowledging sequence number, whereas this can be much faster. You just deliver the packet without worrying about all the mechanisms behind it. So how TCP and UDP works, I explained you. UDP says, okay, I am machine 10110 IP address. I want to send this to you. I would just forward the packet. I don't care whether you are alive or whether you are ready to accept the packet or not. I would just send the packet. That is my UDP communication. On the other hand, when TCP wants to communicate, it would go ahead with a different approach, what we refer as TCP three-way handshake. What happens in this approach, let's say this device wants to communicate with another device, it would first say, hello, are you there? So that would send something called a sync packet, a synchronization packet saying, hey, are you there? This person says, yes, I am there, and tell me how I can help. And then it acknowledges that, okay, I got your message. Tell me how I can help. And then it says, okay, thank you for acknowledging my message. Now let me start the communication. So first the communication is built and then the data transfer happens. So first we send a synchronous packet sending to this device and asking, are you ready to accept some package? This device says, yes, okay, I received your packet and I am ready to accept some packet. Tell me what you need. We say, okay, fine. Now I am going to send you packet. Thank you for acknowledging. And now we start communication. So that is what is happening when a three-way handshake happens. That is a very common question people ask in interview, three-way handshake of TCP. So I hope this thing is clear and you got a better understanding of what TCP is and what is UDP. Let's talk a little bit more on the protocols we use. So TCP and UDP both are used in real world. They have their own use cases. I'm not saying one is better than other or one can replace other. We need both type of thing. We send postcards also and we send registered email also depending on what our use cases are. So TCP applications are file transfer protocol, FTP, HTTP, SMTP, Telnet. They are all connection oriented protocol. Whereas other protocol like TFTP, SNMP, DSCP, DNS, they may not be using TCP and they may use UDP behind the scene. So it depends. Remember, I have showed you the example of different protocols which we have, and in that some of them may use TCP, some of them may use UDP, but they have to use a transport layer protocol for communicating further. So that's how your TCP and UDP protocol can be utilized. I hope this thing is clear. Now, talking more, we have something called acknowledgement system. So here, let's say these two devices are talking. I would send a packet and say, hey, I am sending sequence number 10. So this machine will say, okay, I received 10. Now I am ready to accept 11. And similarly, this machine would also be sending some information. So they would have all the sequence number also. So sequence number 10 packet is sent and it says, okay, I got it. I am now waiting for 11. Now what I'm going to do, I would be now sending sequence number 11 and now I would say, okay, I am ready to accept 12. So this is happening behind the scene. You don't see it. It happens all the time that every packet is acknowledged and based on that a packet is received or retransmitted. So acknowledgement happens in TCP. Devices acknowledge that we received the packet and based on that your transfer would happen. So I hope this thing is clear and you got a better understanding of how this TCP IP communication works. One more thing is about something called TCP windowing. Now, let's say these two devices are communicating. Here we send S1 one sequence number. This device receives it and say, okay, I am ready for A2, means send me the second packet. Now we realize, okay, this person can handle packet faster. Why don't I send him two packets? So S2 and S3, we send two packets, two sequence numbers. This device received it and says, okay, I am now ready to accept A4. So what I did, I increased my window of transfer. How many packets I was transferring initially? Only one. Now I am transferring two packets. This device accepted it, no problem. Let me now try to increase window again. And now my device here transmitter says, okay, let me try to send S4, S5, S6 and S7. Multiple packets sent. Now maybe this device was not fast enough to accept all four packets and it says, hey, I was able to get 4, 5 and 6, but I could not handle 7. So I'm still waiting for 7. So it says, hey, I got 6 and I am ready to 7. We realize we already sent 7. Probably this device cannot handle that many packets. So let me come to a smaller size of the window. And now maybe we sent 3 packets and then it says, okay, I received 7, 8 and 9 and I am ready for 10. So we have come up to a window size here. This happens automatically behind the scene in communication, but good to know these fundamentals. So that is called TCP windowing. All this communication happens on a port number. A port is like a window on which you go and talk. Like you go to a bank, right? And a bank may have a physical address. Let me try to draw it. Give me a minute. Let me try to get my pen again. One more minute. Yeah, let's start. So let's consider you are going to a bank. And in that bank, what you would have a, sorry, my pen is not working. Let's try again. So this is my bank. That bank would have an address, right? That is your IP address. So you send packet or you go to that bank, and within bank you would have different counter. Let's say this one is for loans, this one is for cash deposit, this one is for check deposit, this one is for insurance or something. So once your packet reaches to destination, once you reach to bank, you need to now go to that specific counter or specific location to get your work done. That is what we referred as a port number. So within your machine, you got one IP address, but you may have web server running also. You may have your email server running also. You may have databases running also. You may have your XYZ service running also. So each of these service would be waiting to respond on a specific port number. Let's say I am waiting to receive packet on 80 for web, 110 for this. I'm using 3069 for databases and 1259 for XYZ per service. So that is referred as a port number. So every time an application communicate over the network, it must not only choose the protocol, but it also has to generate some port number whenever I am sending. So my web browser here is sending request to amazon.com. That is going on amazon.com either on 443 port or port number 80. So port number are required. Port numbers are auto generated. You don't have to manually do anything of that. Port numbers are divided into 3 categories. First one is 0 to 1023, which is called well-known ports. Then we have 1024 to 49151, which is like a free to use depending on your application. And then dynamic or private port that are from 49152 through 65535. So total we have 65535 port number. Some common port number we should be aware about are these. Again, it is not an exhaustive list. TCP 21, SSH, Telnet, SMTP, DNS server, HTTP, POP, R443 for HTTPS. These are some common port number which you will see into your application. TCP applications are more common, as you could realize. Now UDP also uses things like DNS client. 69 is for TFTP, and if you look here, DNS server is using TCP communication, whereas DNS client is using a UDP communication. So it can happen that same service may use different type of communication and port numbers for different type of thing. It purely depends. TCP applications are more common than UDP. So it depends on what you want to achieve. So I hope this has given you a good refresher on the basic TCP IP. It's not an exhaustive thing, but it is good enough information to get started with information. Get with your networking. Now, in the next section, we will talk about how AWS networking works into real life.